Hello friends, in this experiment we'll identify the values of overall input resistance of this amplifier. We can also call it as the input impedance, output impedance of the amplifier, and how the externally connected shunt capacitor affects the higher cutoff frequency in the frequency response of an amplifier. So before actually coming with the experiment details of this, in the earlier two videos I have shared how to build and simulate this whole amplifier circuit, and we have seen how we can observe the input and output waveforms on the CRO so that we can compare the input and output waveforms which are 180-degree phase shift with each other. Then we have seen the effect of these bypass capacitors and input and output coupling capacitor, how it plays the role in deciding the gain and deciding the lower corner frequencies in the frequency response curve of the amplifier. So the subpart that is remaining with this experiment is how to find out the input and output resistance of an amplifier. So to find the input and output resistance of the amplifier, we are taking the help of, we are considering here the signal source resistance. This is the source of the signal. AC signal to be amplified we are applying here externally. So we are considering this as the internal resistance of the signal source. So it is denoted with RSG. So already we have seen in the previous lectures, smaller the value of signal source, it helps in increasing the gain value, and higher the values of load resistance, it helps to increase the value of voltage gain. And actually its value is lower only for the signal source value. So I have taken here, for example, 760 ohm as a source resistance, that is designated as a RSG, and load resistance I have taken its value to be equal to 1.5K. We can take its value 1K, 2K, 2.5K, 3K up to that values. Now to begin with, so we'll simulate this circuit, but before that, this is the relevant description about this experiment which shows how we can find the values of input and output resistance. So to find the input resistance Ri, we are going to use the formula Ri is equal to V0 dash upon V0 minus V0 dash whole multiplied by 6 RSG. So what is this V0 in this case? V0 is nothing but maximum undistorted output voltage without connecting RSG and RL. So RSG is connected in series with the signal source. RL is connected at the output terminal with respect to ground connections. Now V0 dash is output voltage considering the effect of RSG. In the earlier two experiments or the earlier subparts of this experiment, we have not considered this resistance RSG. Here we are considering it. So by considering the effect of RSG, the voltage which we obtain is denoted with V0 dash. So this formula will give us the value of overall input resistance, overall input impedance of this amplifier. Second important point is how to find out its output impedance R0, output resistance R0, using the formula V0 minus V0 double dash whole divided by V0 double dash multiplied by load resistance RL. See, to obtain the value of output resistance, the RL comes in picture. To obtain the value of input resistance, RSG comes in picture. So it decides the role. So in this case, V0 is similar to what previously, without considering the effect of RSG and RL. Whatever the output voltage we get, that is V0. V0 double dash is output voltage considering the effect of RL and not considering the effect of RSG. So this formula will give us the value of R0. Now next is, so this is what the concluding remark relevant to the effect of RS and RL onto the overall gain. Larger the source resistance and smaller the load resistance, that will reduce the overall gain of an amplifier. So these are the readings which I obtained. Just for the reference I denoted here the values, and input and output resistance value approximately we will be getting these values. So I have given here. So you can simulate and test it. Now gain calculation. Similarly, objective of this experiment is also to find the different gain values. So this is open circuit voltage, we can say maximum output voltage divided by the input voltage. So if the readings are taken with multimeter, it means all the values will be obtained in RMS voltages. These will be, so V0 by Vin. So this is V0 dash by V input voltage. So this voltage gain is considering the source resistance. This is a voltage gain considering the effect of load resistance, denoted by V0 double dash divided by input voltage Vin. And this is a voltage gain considering the effect of both signal source resistance and load resistance. So that will give us this voltage gain value. So our objective is to identify all these parameters. So this is what done in this circuit. So this circuit is already built here. One by one, how to take the readings, that I will show you. See, right now RSG is not connected in the circuit. RL is also not connected in the circuit. Shunt capacitor is also disconnected from the circuit connections. So right now, if I simulate the circuit, whatever the readings I will get, that reading will be of V0 value. So of V0 voltage. So V0 is a voltage, output voltage, without considering the effect of load resistance RL and without considering the effect of RSG. So I am getting the value of 1.634. This is a V0 value. Now I will stop the simulation. Now break this path and do the connections of. So I will connect this source resistance through this RSG and it will be connected in the circuit. Now if I connect it, now I will simulate the circuit. So considering the effect of RSG, whatever the output voltage I am getting, this output voltage is V0 dash 1.631. This is what we have seen in the description part. V0 dash. So V0 dash is which voltage? So V0 dash is the output voltage with RSG and without considering the RL. So this is a V0 dash reading. So this reading is also already I just written here. So it's V0 dash 1. So it's 1.634. So just now how much we are getting? 1.636. So slight variations. And here I think it's 1.631. So little bit smaller variations are there. So it's a 1.631 volt. So this is the reading of V0 dash. So make a note of these readings. Now after this, what we'll do? RSG is connected. Now let us connect RL as well, so that we can get the readings of. So what changes we have made? Connect RL is also connected in the circuit. RSG is also connected in the circuit. So connecting RSG, connecting RL, when you are considering the effect of both these resistance, then whatever the voltage we get at the output, that is called as a V0 double dash. Sorry, it's a V0 triple dash. I will show you the readings. So V0 triple dash is the 0.7 volts. So input is 0.35 volts. 35, it means it's a 35 millivolts and output is 0.7 volts. So considering the RSG and considering RL. So I will stop the simulation. So what is the notation for this in the description? So considering the RSG, okay, it's not added here. V0 triple dash. See, V0 double dash is without RSG and with RL. And if you consider both these parameters, V0 double dash, if you consider both the parameters RSG as well as RL, then whatever the reading we get, that is V0 triple dash. It's a 0.7 volt. Okay, so I think I forget to add it, but make a note. V0 triple dash is with RSG and with RL. We'll come back to the circuit. So this is the reading. Now if I remove this RSG which is connected here, and I will connect it directly. So without considering the effect, I will connect it to the input. Now simply RL is connected. So whatever the reading I will get here, that becomes V0 double dash. So if I am simulate the circuit, so it's a 0.702. 0.702 considering the effect of RL. See, earlier we have seen no load voltage is always greater than the loaded condition voltage. So if we remove this RL, we have seen we get the reading equal to 1.636 voltage. So that is the highest voltage. But by considering the effect of considering the load resistance, output voltage gets reduced. So if we increase the value of this resistance, there will be increase in the value of output voltage. So this was the objective. Now already we have the readings of V0. Then we have the reading of V0 dash with RSG only. With RL only, we will be having V0 double dash. With RL and with RSG, we will have V0 triple dash. So using all these readings, make a note of those readings and find out the values of voltage gains. So that will give us the values of voltage gain. So this is what it is indicated in the description. So these are the different readings. So considering the RSG at 760 ohm, RL to be equal to 1.5K. So I am getting V0 of 1.636, V0 dash is of 1.631 volt, V0 double dash 0.701, V0 triple dash 0.7 volt. So we have to do the calculations of voltage gain also. So for these are the different RMS voltages which are measured using the voltmeter in RMS mode or AC mode, and then note down all these voltage gain values. Then that completes the one of the again third sub part of this experiment. So now effect of shunt capacitor on the corner frequencies, let us see that. So I will connect this shunt capacitor and I will remove the disconnected resistance RL. Now if I go to the simulate option, analysis part, go to the AC analysis, or we can go with the parameter sweep. Okay, we'll go with parameter sweep. So parameter sweep is nothing but change any one parameter, sweep it within some ranges. So C shunt, already I have selected this name of the capacitor. These are the different capacitors. So out of that I am interested in sweeping the parameters of C shunt, externally connected shunt capacitor. So I will change its value from 0 farad to the 30 nanofarad values. So for the two values, we can obtain it for the multiple values also. If I take with the steps of 4, it will be giving us the 4 different plots. So 0 to 30 nanofarads. So this is the graph what we will be obtaining. So this graph indicates that, see the red color line. So red line indicates this is for 0 capacitance. It means if I don't connect the external shunt capacitor which is connected now, then I will be getting this response. This response already we have seen in the earlier second video relevant to this experiment. So these are what is the indication of these 4 graphs. This graph indicates that the way we go on increasing the value of externally connected shunt capacitor, it affects the lower cutoff frequency. So this was the objective. So this is the magnitude plot, this is the phase plot. Also the connection of externally connected shunt capacitor, it will affect the phase plot. It means how there is a variations in the phase shift value between the input and output waveforms, that is shown here, that is in the phase plot. But we are more interested in the magnitude plot where it indicates that connecting external capacitance, if it is not connected, this is the normal graph which will be obtaining, but by slowly increasing its value. So this is a violet color, it indicates 30 nanofarad, and this is for the, in terms of the 0 to 30, it has been divided into the 4 steps, and we are obtaining the 4 graphs over here. So as we go on increasing its value, its effect is observed, it affects the higher cutoff frequency in the frequency response curve.